Hello everybody, welcome to another exciting math video. In this video we're going to look at topic 2, lesson 6, example 3, and in this video we're going to touch base on something called the discriminant and how the discriminant can help us find the type of roots that we are going to be working with. Like if you have two roots, one root, or no roots. And when I mean root, what I really mean is how many solutions or how many times our graph either crosses or touches the x-axis. So looking at this, we have three different graphs with three different formulas. And what they want us to do is they want us to use the quadratic equation to solve for these. So I have my graphs here. I'm going to have a reminder off to the right. Let me see. I'm going to choose, I think this lilac-y gray color. And I'm going to put x equals negative b plus or minus the square root of b squared. I like how I just put the 4 there. B squared minus 4ac. We talked about this in the last example. All over 2a. And remember, the whole thing is over 2a. A common mistake that I see is people forget to put this negative b over that 2a. All right, so the first thing I'm going to do here is I'm going to determine from these three equations what my a, b's, and c's are. So red equation is going to be the first equation. My a here is going to be 2, b is going to be negative 7, and c is going to be 3. Notice how these are just the coefficients. There are no x values tied to my coefficients. So this is coefficient a, coefficient b, and coefficient c. A equals 1. I don't have a value in front of the x squared, so that's implied that there's a 1 there. B equals 2, and c equals 8. All right. Now let's do this. I'm going to use that quadratic formula, so x equals negative b, negative parentheses, negative 7, plus or minus the square root of negative 7 squared minus 4 times 2 times 3. The full thing is going to be over 2 times 2. All right, I'm going to clean this up a little bit. I have x equals negative times a negative is a positive 7 plus or minus the square root of, and in my calculator, I'm just going to put this in here, negative 7 squared. And notice how I put the parentheses around my negative 7. That's because I want the full number when I put it into my calculator to be squared. I want to add those parentheses as well in my calculator. So I get 25 divided by 4. All right, the square root of 25 is going to be 5. And now we have two different solutions. We have 7 plus 5 divided by 4. And we have 7 minus 5 divided by 4 because we do have this plus minus here, which again makes it two solutions. All right, so 7 plus 5 divided by 4 is 3. And 7 minus 5 divided by 4 is 1/2. All right, so there are my two solutions for the red equation, or this first one. And we can see on the graph, we have, sorry about that, we have two places where our function goes to the x-axis. Therefore, we have two real solutions. This one, looking at this one, it looks like we're going to have one solution, but let's use the quadratic formula to discover this. So again, we have x equals negative b plus or minus the square root of b squared, which is 144, minus 4 times 9, 4 times 4 times 9, which is 144, all divided by 2 times 4, 2a. 144 minus 144, that leaves us 0, plus or minus the square root of 0 divided by 8. The square root of 0 is 0, so we really don't have anything here. This falls away. This drops away. So now we have x equals negative 12 divided by 8. Which is going to be, it looks like it's 1.5, and that's what I got. Or 3 halves. 1.5. Whatever it is a single solution. All right, so let me even these out here. X equals, I did fraction there, so let me do a fraction here. All right, so the last one is blue. Let's look at blue. So we have x equals negative b plus or minus the square root of 4 minus 4 times 8 times 1, which is 32, all divided by 2 times 1. X is going to equal negative 2 plus or minus the square root of negative 28. Okay, I'm going to break 28 apart because I do, like how I just picked the same blue color, I do want to simplify this radical. And so I'm going to take negative 28, I'm going to break it into 3 pieces. I have negative 1. I'm going to look for a perfect square that goes into 28. So this is going to be 4 and then 7. 4 is my perfect square. 7 is going to be basically what's left over. Remember, these are all square rooted. So looking at this, I'm going to have I for this first one, 2 for the second one, and I can't simplify square root of 7 anymore, so that's going to be the square root of 7. So now, taking my simplified version of the radical, I'm going to put it back into my equation. So this is 2I root 7, all divided by 2. Now, another thing that people forget is that this 2 needs to divide into both these terms. So do both these terms, can they be divided by 2? Well, they can. Luckily, we can. So you have x equals negative 1. So negative 2 divided by 2 is negative 1, plus or minus. This 2 can be divided by 2. So 2 divided by 2 is 1. So we're just going to say I, because that's 1 times I, root 7. We have 2 complex numbers here. We have x equals negative 1 plus I root 7, and we have negative 1 minus I root 7. 2 different solutions. They are complex. We still have solutions here, but looking at the graph, it does not even look like our graph even goes through the x-axis. So even though we have solutions, we do not have a graphical solution. We cannot see where this goes through. So that's where this imaginary number comes into play. All right, so there are my 3 solutions. This introduces the idea of what's called the discriminant. So if I look here, we notice that when we have the square root of a positive integer, or positive, it doesn't have to be integer, a positive number, we have 2 different roots. When we have the square root of 0, we have 1 root, and when we have the square root of a negative number, then we have 2 complex roots. And this gets into the idea of the discriminant. So take a moment, pause the video, and write this definition down. All right, so now that you're back with me, the radicand in the quadratic formula is what determines the nature of the root. So the radicand is this guy right here. This symbol is a radicand. So this is going to determine how many roots we have, whether we have real roots, complex roots, or a single root. So let's keep reading what they have to say. The discriminant. So this whole root b squared minus 4ac, this right here is called the discriminant. Here we go. not come in highlighted. This is the discriminant right here. And this determines if we have 2 real roots, 1 real root, or 2 complex roots. So if the discriminant is greater than 0, we saw this in the example. When it was 25, we had 2 real roots. 25 is greater than 0, and so therefore we have 2 real roots. When our discriminant, when our b squared minus 4ac is equal to 0, then this is 1 real root. So again, we're looking at this inside this discriminant. What's happening inside this square root? What's happening inside the radicand? And when that discriminant is less than 0, when we have a negative inside that square root, you're going to have 2 non-real or 2 complex roots. All right, so the discriminant helps us find the roots very quickly. It's a great tool to see if you actually are on the right track to the correct solutions. And it's just another way to identify what's happening with the graphs. So if you guys have any questions, please get a hold of me, and I hope you guys have a fantastic day.